Hi everyone. I think we're going to get started so we can end early or on time. Cohen, can you check on WebEx if they can hear well? Okay. No problem. Okay. Hi everyone. Welcome to the second Woman in Tech session of March. My name is Serpil Bayraktar and I'm the program lead for VIT. I'm also a principal engineer here at Cisco in Chief Technology and Architecture Office. As we all know, cloud has been a very important topic for the last several years, but it seems like we're entering a new and maybe more mature era of cloud technologies, where we're now talking more about a dynamic and hybrid ecosystem and all the services that this system enables. The focus shifted from talking about cloud to more like the cloud stack. Our guest speaker, Jennifer Lin, is going to talk about some of these very important shifts happening in cloud technologies. If she looks familiar to some of you, it's because she spent a decade at Cisco working in 3 different BUs: ISR, Enterprise Mobility, and Emerging Technologies. After Cisco, she joined the founders of Contrail as the lead for product management, and Contrail was acquired by Juniper in 2012. Currently, she is the Director of Product Management at Google. And please help me welcoming Jennifer to VIT community. Thank you.
Okay, good morning, and I'm super excited to be back on Tasman Drive. It's always fun to see old familiar faces and see kind of the new faces as well. So thank you for having me here. We're just coming off of last week. Google did a Google Next up in San Francisco in Moscone. It was the largest conference that Google has done. It was a user conference for cloud, and I think we're seeing quite a change, and it's growing very quickly. So I wanted to talk today a little bit about number one, why we think this is sort of a different model, definitely for cloud. We're really introducing, I think, a new phase for cloud, but also what it means in terms of software delivery and the pace at which software is being delivered. No problem. You don't want me to do karaoke up here, so. Okay, so open cloud services and software agility. Hopefully you'll get the sense that not only do I speak fast, but things really are moving fast. And that is a huge change. For cloud, a lot of the initial phase was reducing cost and doing infrastructure as a service. This is really about the value of software on top. So Serpil gave a little bit of background on me, so I won't go into that. I grew up on the East Coast and have been out in the Bay Area for about 20 years. I've been at Google for about a year, driving a product management team focused on security, privacy, networking, a lot of the services platform work where we are bringing on third-party ecosystem partners as well as open source projects into the platform with microservices, et cetera, as well as some of the horizontal services around telemetry and billing, et cetera. I have 3 boys, ages 11, 13, and 15, and they are teenagers. Yeah, I mean, I think the thing around software as a service, folks probably know Google a lot for being one of the top 3 SaaS providers with what was recently rebranded as G Suite. And the cloud platform is essentially the other major component of our cloud business. Diane Green came in a little over a year ago to essentially drive this business. She had been on the board of Google for about 5 years and now leads essentially the cloud organization. About a year ago when I came into Google was really looking at sort of opening up the cloud to enterprise. And as many of you know, Google has been focused a lot on consumer and SMB with most of its software development. And when I was at Cisco, one of the key trends around mobility was very much consumerization of the enterprise and the need to open up things like BYOD and enabling and empowering employees to kind of work outside of the corporate walls. So a lot of what Google has done, and I'll talk a little bit about the way that the employees work there, but a lot of what we're doing with cloud is externalizing what Google has learned over the past decade plus. So for us, a lot of this next phase of cloud is around data and building these systems of engagement using real-time data, a feedback loop that essentially puts the data back out, does things like behavioral analysis, fraud detection, learning systems for whatever it is. We've talked a lot about our focus on some key verticals, including things like healthcare and financial services, where a lot of our customers are really unlocking the power of their proprietary data that they've had for some time, and more importantly, sharing that data for things like research and collaboration. Last week I had dinner with about 20 leads from higher education. Google works a lot with the universities around collaborative environments. And in the cloud, obviously, this just becomes a natural platform to share massive sets of data, whether it's with academia or other corporate entities. So for cloud, we really are taking what was previously the technical infrastructure engineering team, thousands of engineers who have been really focused on supporting the platform that serves the Google properties, YouTube, ads, search, etc. And cloud is really with the cloud platform, we're really externalizing what Google's learned around delivering infrastructure as a service and platform as a service to keep the developer agility very high. At the bottom there, you see some of the icons of Google properties that are over 1 billion users, and obviously there's many of them. Some of the more familiar ones, Maps and Drive and Chrome and Android. But you can imagine that in having sort of the mindset of we want to build an infrastructure that really keeps the developers happy and abstracts the infrastructure complexity. Obviously, you hear that a lot today with cloud as IT organizations kind of get out of the business of saying no and pushing back on teams that are looking for infrastructure, but more thinking about how can we accelerate what they're trying to do and not expose all the complexity of the infrastructure. So this is really, as a product management lead, a fun job for me. We have a lot of goodness that we're really productizing as a service and opening up to enterprises and our customers. Our CEO has kind of talked a lot about machine learning isn't really a product area. It's really about the way that software will be delivered moving forward. So how do you use essentially neural networks and these trained learning models to essentially unlock the power of the data that's there? And it isn't just static. It's obviously constantly learning. So some of the more familiar examples with autonomous vehicles, Google Home. I mean, it's great for me to essentially talk to my Google Home and get a quick answer, but it also obviously learns over time your preferences, et cetera. And then we use a lot of machine learning in all the Google properties, including YouTube, et cetera. So this mindset, and if you see the interest from the universities in terms of the computer science curriculum around machine learning, we just also acquired Kaggle, which obviously runs very large competitions around data. If I look at my kids today, they're writing little Python scripts, and they're doing a lot in the gaming world to essentially get real-time feedback in their player statistics. So there's a lot of context there that is being presented back into the way applications are being built. So fundamentally, it's about a different way of delivering, developing, and using software. This is just a smattering of some of the customers in cloud that we've been public with. Obviously, there's a lot of familiar consumer brands. If you take someone like Snapchat, who just had, I think, one of the largest IPOs in history, and the rate at which they've grown, this is sort of a different type of infrastructure. Our engineers work very closely with a lot of the engineers in these organizations, and it's also sort of a really cultural thing in terms of how we believe this model of growing a platform is different. Working collaboratively with the engineering community and the open source community. I'm also a good user of Spotify. Every morning it gives me my playlist. There's a recommendation engine there that essentially knows my preferences. I'm not listening to the same thing every day, but it essentially knows the type of music that I like. And then, for enterprises who essentially have been really thinking about how do they disrupt themselves and sort of work in this type of environment, many of our traditional enterprise customers, whether they're in automotive or oil and gas or defense, are starting to see themselves as software development houses. So if you were a car manufacturer last decade, now you're basically developing software that will essentially, talk to an autonomous vehicle, but essentially enhance the mobile experience of the person in the car. That's a very different mindset in terms of, how we build these systems. And that vehicle also needs to be very aware of the context around it. So many enterprises are feeling the urgency to not just work within the walls of what they've done as a multinational global enterprise, but essentially share and collaborate with data sets. If you take a customer like Citigroup, they spoke on our behalf at the last cloud conference in London. They just finished a proof of concept for risk analysis where they essentially just for the proof of concept, ingested about 4 petabytes of data and essentially used machine learning to come up with models to do risk assessment in their environment. For many of these financial services customers, the intent is that they develop these models and they contribute them back to the cloud platform on behalf of the industry. So this is a very different mindset of, hoarding data and the intellectual property, and more, let's as an industry accelerate the pace at which we can all move forward. We've been asked a lot, a lot of the audit and compliance requirements that have slowed down many of the enterprises as sort of overhead. We're having a very different discussion around how do we automate a lot of the audit and compliance and regulatory models so that essentially these don't become, very large processes and onerous overhead for the enterprises. And then finally, for media and gaming, where a lot of the young computer scientists want to go because it's very exciting, Pokemon Go, I think, broke 5 Guinness World Records when it came out, and within the first 2 hours was 50x its full forecast. So you can imagine sort of the elastic scaling of the infrastructure that needed to happen, because there is no forecast that could have picked that up. And it was pretty much global very quickly. For the developers, and Niantic Labs spun out of Google, but it was a very small team of engineers. So in their wildest dreams, moving organically and building their own infrastructure, I don't think they would have imagined that they could go global that quickly. But you can imagine with these types of systems, augmented reality, where essentially the game knows who you are and your player statistics and where you are, through essentially the geomapping context, the way that people are thinking about software is pretty different. Within cloud, we expose a lot of APIs. For the platform itself, you have, the infrastructure APIs around storage, compute, and networking services, and this is obviously just a partial list. On top of that, for advanced data analysis and a lot of the things that we've done to externalize machine learning as part of the platform, you can see the Vision API, natural language processing, how do we do translation services. These are all just part of the platform services. We also just announced last week video intelligence APIs. So as folks are sort of ingesting a lot of their video content, we can obviously pick up patterns in that weren't really they weren't aware of before. Some of the other ones, just obviously YouTube APIs we've always had for things like search and ads, lots of analytics capabilities, and those are also now just part of the platform. So you can see it's not just about sort of the last round of cloud, which is really infrastructure as a service. And then, as I mentioned, on top of that, with G Suite, formerly known as Google Apps, this is now part of the cloud platform. So that in and of itself is a large SaaS service on top of the platform. And a lot of our enterprises are moving, their office productivity to that type of model, especially as they start to bring on students from school. So most of the universities in K through 12 education use G Suite today in the campus environment. So that type of mobile-first model becomes very natural in the enterprise, which wasn't the case before. We also have a huge commitment to the open source community, and just some examples there. The original work around MapReduce for batch processing and big data was done, within Google and then externalized as Hadoop. We've recently open sourced a lot of the machine learning tools with TensorFlow, and last week showed a lot of the examples where various verticals are using those machine learning engines in their corporate environments. But we do a lot of investment around the open source ecosystem and building the communities. Some that are specific to cloud, we started the Cloud Native Compute Foundation, and with the sort of explosion of containers and Kubernetes is really the open sourcing of the cluster management and container management that Google's been doing in its own environment for many years. I think the statistic they use is we launch 2 billion containers per week within the Google environment. So we've learned a lot about managing these types of workloads at scale. And Borg is the name of our internal controller. That type of architectural model was externalized with the Kubernetes model. And that's become, I think, one of the top open source programs in the industry in just a very short period of time. So the move to containers also abstracts, the tie to the infrastructure. So the model of I can, write a container once and run it anywhere, whether it's a Google Cloud or someone else's cloud or my on-prem data center environment, is also changing the pace at which folks can kind of adopt these models. The ecosystem is very much around, obviously, the development community, which is where these applications start and where Google, the heart of Google's employee base is in terms of development. But as these new applications are written, a lot of our job from a product perspective is making sure that we meet the needs of both the administrators as well as the end users themselves. So Google has always been very focused on using data to enhance the end user experience, whether it's Android or Chrome or some other application. And there's a huge investment in UX. We usually start the product delivery with UX research and then tie that through, obviously, in the user stories. Not uncommon in software, but I think because a lot of these UX investigations are net new to a lot of the folks that are trying to make this migration, it becomes an even more important exercise. And the platform itself, obviously, is runs on a network that Google's quite proud of and has invested in over the past couple of decades. We said publicly last week that we spent almost $30 billion in CapEx over the last 3 years to build out the infrastructure on which the cloud rides. So that type of capital investment is not for the faint of heart. And that's why we believe that as the cloud moves into this next phase, we're advising a lot of folks to get on rapidly and not try and rebuild that type of environment in your own corporate environment. And that's pretty tough for a lot of the folks who have been doing essentially the maintenance of their own platform infrastructure for many years. We're also open sourcing the RPC mechanism that's been used across the microservices in the Google environment, and that's gRPC, Google RPC. And really, once again, this is just a technology that allows developers to not have to worry about the bindings across various languages. So it supports up to 10 languages. We can enable sort of service-to-service communication and structured data very rapidly. And this is based on a technology that was powering a lot of Google's services for 15 years or so. So that allows, once again, and the theme of agility being that if we can put into the tool sets the abstraction, whether it's C++ or Go or Java or whatever it is, and just think about the service itself, then we can essentially allow a lot of services to talk to each other and build this collaborative ecosystem. Part of the intent of open sourcing it, obviously, is to make sure that it's relevant not just to the Google development model, but also to where we see cloud going. And already we've seen a lot of the cloud native providers kind of pick it up and use it in their environment, Stripe and Lyft, et cetera, and often in a containerized model. So containers also took off just because now, unlike VMs, the developers didn't have to worry about the infrastructure specifics and could just focus on the content that they were developing. From a network perspective, the folks have been saying the network is the platform for some time, but this is really a huge advantage from a Google perspective because for over 10 years now, they've built out a global network that essentially moves the edge as close to the user as possible. So we have US to Asia last year laid down the fastest submarine cable in the globe, 60 terabit per second link to Japan, and we're laying down another one next year, which essentially will connect at faster speeds down to South America. But already we have 100 peering points and over 80 POPs that interconnect this global private backbone to essentially the end users who are obviously in those geographic areas. And the investment that we'll be making over the next couple of years is really to bring up an unbelievable number of new regions and zones to serve essentially our global cloud customers. Some of the things specifically, a lot of folks have been a little bit frustrated with sort of the lack of instant global access in other cloud environments. And here, obviously, this is externalizing the way that ads and YouTube, et cetera, have been delivered for some time, putting those points of presence and essentially presenting the services. In this case, through the global load balancing that is part of the cloud platform, presents a single service virtual IP, right? So you call a service, and that essentially optimizes how that service is delivered to the various backends. And that same sort of infrastructure is being used for the content delivery network, which means that we can cache content as close to the user edge as possible, and also open up that infrastructure to our CDN partners like Akamai and Fastly and Cloudflare, et cetera. We also, that also means that at the edge, which obviously is the start of the platform itself, we can absorb, DDoS attacks. And I think that's sort of an unspoken benefit of essentially this approach of having the edge as part of our infrastructure. We can elastically scale to absorb very large DDoS attacks because we can load balance across the entire globe. It's very unlike the way that most DDoS systems work, where essentially they're using DNS and they have, they can't automatically scale that to statistics like this, over 1 million queries per second with no pre-warming. So that's a very different model of load balancing. It's not a thing, and it doesn't use DNS. It's essentially auto-scaling across the globe. Part of the changes, too, in terms of how we have to externalize those network services to our customers is really to make sure that everybody has sort of a private environment that they can use and attach whatever policies that they need for their specific environment. So we invest a lot in the notion of creating a virtual network segment that essentially is their own sandbox for a specific team, and attaching policies to that, security and network policies, in a very software-driven way. There is obviously no tie to locality or the hardware itself there in these services. A lot of the network services, layer 4 through 7 services, as they're often called. And then we have one of the most extensive peering policies, so we can interconnect essentially to pretty much most of the major ISPs and carriers with a very open peering policy. So this is not a nailed-up connection. And that's also something that Google, I think, has been distinguished in, because that allows us to essentially easily peer with whoever to essentially get global reach. I talked a little bit about the global load balancing, but it's really sort of at the heart of the cloud and the model of sort of global reach. We can essentially support any user in any location, whether they're coming in through IPv4 or IPv6, and do essentially load balancing for HTTP, HTTPS, TCP, and SSL connections at various layers. So we can essentially point to the right backend. We sort of bring the user on as close to the user as possible. We point and optimize to the right backend. This is all obviously seamless. So a lot of the experience that you see with your search results, right, is because we have this type of infrastructure. Cloud Spanner is another example where we're fundamentally using the network as the base for a new type of database. And this was also highlighted last week. Here we're able to horizontally scale globally, elastically with a NoSQL database, but the key thing here is that we can put SQL-like semantics on top of it. So we can query a real-time transactional, globally consistent database with SQL-like semantics, which is quite a feat of engineering, and a lot of the challenge has been getting essentially these data pipelines to present the data in a way that essentially can be served up with very SQL-like semantics. I want to ask a very specific question, but I want to make sure that that data is served up in real time, and I have consistency across the sources that it's being served. By the way, this is the backend that's being used for AdWords. So once again, another example where a lot of the productization of the cloud is essentially externalizing a lot of the lessons learned with some of the biggest properties within Google. So I'm not going to go through all of this, but just an example of the product focus around the data platform. If you can imagine ingesting the data, storing the data, putting it into the appropriate databases, preparing the data and processing the data, analyzing the data, and then essentially start to put machine learning models on top of that data, so essentially you can just call a service. This is, as folks try and piece this together, becomes very difficult, whether you're a developer or a data scientist or an analyst. So a lot of the focus in our cloud has been around how do we make these types of data, which are obviously being generated with IoT sensors and mobile devices, as well as instrumentation from various infrastructure platforms, more usable more quickly. We also have to, think about, as one of the benefits of the cloud is I essentially want to self-provision my environment, and I never want to file a ticket to anyone. Sort of these best practice templates, what we're starting to see is one of the biggest use cases for the cloud is really essentially developers looking to essentially move quickly with their own sandboxed environments. For the administrators, they want to make sure that they can pass their audit and compliance, and that they have sort of laid down certain security and network policies a priori, and that needs to be global. So if you think about, I as a user want to be able to create my own projects. I want to work in a self-provision way without asking anyone for permission, and I want to peer to another project once I want to share that workload out to another team. So a lot of this sort of network as a service model is fundamental to how we're doing the platform environment, but it's not sort of networking as a separate vertical. So from a security perspective, we have over 750 engineers who are essentially doing security research, threat intelligence research, as well as delivering the security platform itself. And we talked last week about how we really create a hardware root of trust in the hardware and the chipsets that we actually build. We also partner with, and we had up on stage, partners like Intel, but we do our own chip design, and part of that is because the type of hardware boot chain that we need to do to make sure that when you boot up a server, it essentially has a machine identity that is checked up this stack. So we harden our own kernel, we essentially harden the OS, make sure that every service that comes online is essentially authenticated against that machine identity. So once you break that hardware boot of trust, you can't just use a third-party server and achieve this, because you don't know if that machine should be trusted. We cryptographically sign essentially all the images and the binaries on top, and then we give a lot of tools to our users, in their space to essentially empower them to set their own security policies, et cetera. But we issued a white paper around, the layered security model, and really just explain this in detail. We also put out a white paper that talked about how we think about encryption. So everything is encrypted, data at rest as well as data in motion across the network. And the model for encryption at rest is also something that is I think very distinct from the way that other cloud providers are doing it. And we issued a white paper there to show how we think about encryption for data at rest. We also announced a product that allows our customers to essentially manage their own keys in their environment, the encryption keys. So some customers want to be able to determine with what frequency they rotate their keys, as an example. So that gives them the ability to do that. I think in terms of the simplifying how the environment is managed, simple policies like who can do what with what resources. So we think a lot about this in terms of the identity and access management environment. And this is not just users, it could be services or devices. So interrogating essentially the users and devices when they try and access a service, and essentially setting up policies that predetermine sort of based on the audit and compliance rules or the internal policies who can do what. This is all sort of software-defined infrastructure that meets the use, in this case, of the administrators. Part of my team also is responsible for the telemetry and monitoring piece. So obviously we do a lot of that in the platform itself, and then we have a lot of tools in the cloud environments for our customers. But one of the things here is it's not just about the tools and the software. Google has a very distinct way of sort of operating these environments and automating the environment at scale. This book was written by some of the leads of the SRE team, Site Reliability Engineering. And as we brought our cloud customers on, one of the things that we've done is essentially put SREs specific to customer environments to help them get into this model of process, which often is heavily automating the environment and only managing by exception. So there's been a lot of training, and as we've brought on, the services customers and partners as well, to make sure that this cultural and process change is essentially embedded in. One thing that we also externalized is essentially the way that the employees work. And as an employee at Google, the assumption is you can work anywhere and you're on a trusted device. So when you essentially authenticate in, the boundary essentially checks your user and device and issues essentially the credentials against a very specific application access. So this is based on a model called Beyond Core that was essentially published by Google a couple of years ago. And in the cloud, we've recently just made this part of the platform, externalized as what we call identity-aware proxy. And this model of sort of taking the context, who is the user, what device are they on, what application are they allowed to access, where are they, do they have a risk profile that's greater than it should be. If I'm a disgruntled worker, even though I'm Jennifer Lin and I have a trusted device, I may need to be blocked because I may access something I'm not supposed to, for example. So it's a much more granular model of access control, and that works obviously for native applications in the cloud, as well as third-party applications that you may be using single sign-on to access. The little animation there is also, the security key. So one of the folks on my team is president of the FIDO Alliance, and the FIDO Alliance has really been looking at standards for identity and access control, and externalized, folks like Google and PayPal and Microsoft have been working on this. A lot of our enterprise customers essentially want that model of multi-factor authentication because one of the biggest risks within the enterprise today is obviously phishing attempts. So making sure that we can strongly authenticate a user, a device, and check credentials with strong auth is really a new model. A new model for enterprise security because obviously the model before was sort of put a hard exterior around it and leave the inside. Assume that within the walls of the enterprise people are trusted. Here it's really more of a zero trust model with a more granular access control. But what that means is that I can sit at Starbucks and easily access whatever application I need to. So in terms of the data and data control, one of the biggest challenges that the customers are seeing is that they've kind of grown up with these monolithic legacy systems and they don't even know what data they have anymore. So because their businesses are being disrupted, they now need to share the data and they don't even know when they're exposing personally identifiable information, which is obviously a risk and means that they may not pass their audits. So PII is one of the major areas that really hadn't gotten a lot of attention, and one of the reasons why, as people move a lot of their data into the cloud, they're now saying the cloud is more secure than their on-prem environment because they have a better sense of what they have. And I'll give you an example. So I may have a very large data set. I've got credit card numbers or social security numbers or sensitive information in that data set. And when I share 4 petabytes of data, I didn't realize that I actually shared it. So that model of sensitive data, now detecting and classifying that data, we've now externalized the capability with what we now call our Data Loss and Prevention API. It has over 40 content detectors, so it can look for across images and text and pick up that data and make sure that it's filtered out. So if you could imagine, I spent 2 weeks ago 4 hours with the chief data officer of a major healthcare company. And they had spent the last 2 years essentially de-identifying the sensitive data in their on-prem environment. As they came into the cloud, they ingested a lot of the data, and as a proof of concept, just essentially checked that the data that they thought that they had spent the last 2 years de-identifying was picked up. And indeed, this is a very quick way to sort of automate that process. And this is not just, let's say, for healthcare researchers. For healthcare, the NIH and the CDC, they've long since put their research data, the government entities long since put their data in the cloud. Now you see all of the pharmaceutical companies, research organizations, et cetera, they're not going to be able to do their genomic sequencing or cancer research without sharing data, their own data, with those very large data sets. But as they share that data, they want to make sure that they've classified, detected, and redacted any sensitive data, and then it gets put into essentially the research environment. And that's where the intersection of, let's say, a lot of the large universities and the corporate environments and the folks doing the research, even an individual essentially sharing that data or trying to understand that data is really breaking traditional boundaries. If you think about mobility, a lot of the early innovations in mobility happen in the university campuses. And when I was at Cisco, a lot of the mobility services and location services, we would essentially test with the graduate students just because they're willing to try new things and because they're trying out sort of new use cases that nobody's really thought about yet. So I went through that fairly quickly. I kind of pulled out some content because I figured we might run out of time, and I'm sure I missed some things that folks wanted to talk about. So we left some time at the end for Q&A, and it looks like we've got some. So, one more call to action. Obviously, the approach that we're taking here is to build sort of collaborative communities. So part of my goal and interest in coming and talking to all of you is, there's very much a recognition that there's no one company that's essentially going to do this. We're putting a lot of investment into not only working with our customers and partners, but also finding new ways to sort of stimulate the community and share across the community. Our developer relations team at Next last week essentially did a big push. We're doing a lot of meetups, a lot of community engagement, a lot of open source environments to share. So, yes. Oh.
Being a non-technical person, that was excellent. What I wanted to ask was, obviously everything that Google builds is very technologically superior. That said, in the cloud market, AWS is still the leader, followed by Azure. So how do you plan to catch up, especially in the enterprise sector?
Yeah, I think that's where, we believe we're in it for the long game, and this is just the beginning. So yes, AWS kind of knocked it out of the park the last decade with sort of the model of TCO and reducing cost for infrastructure as a service. I think Google looks at it quite differently and more about the layer on top. And obviously, we never lose in terms of the infrastructure, but essentially I think we're thinking about it a little bit up the stack. So it's, we have obviously the investment in compute storage network services, but things like machine learning are highly differentiated. And often the reason, the data services and the machine learning are the reason that we see a lot of folks moving into GCP when they may have, in the last phase, pick someone else. We also have a commitment to, moving forward, there is not going to be one cloud. And I think you'll see some of the others basically, give away the cloud environment to essentially retain the market share on the applications on top. So I think the commitment to sort of loosely coupled systems, a lot of times you see essentially parts of our offer, loosely coupled to other things. So the tooling we're also open sourcing. That's often one of the issues that folks have in, other environments. I think open source is one of the biggest differentiators as well, just because the pace at which that's moving and the ability, the way that the engineers are working with folks that actually may be, on paper their competitor, but moving as an industry at a faster pace. Yep.
So one of the concerns with moving to cloud services, and especially microservices and containers, is the multi-tenancy aspect of it. So I know you kind of briefly touched upon that, but do you have any tools or resources we can check out to see what you guys...
Yeah, and actually even before I got to Google, a lot of what we were doing with Contrail was just that, solving some issues around microsegmentation and security policies for a lot of the SaaS providers, and other enterprises who were building VPC environments on-prem. So folks like GE Predix, their IoT cloud, leverage our software. And of course, because they were onboarding 5,000 ecosystem partners, they needed to make sure that they had security all the way down between containers on the same host. So that model is absolutely a design principle in cloud. If you look at essentially the way that people started to do it was, let's say, to put a virtualized firewall and make sure all traffic goes through that gateway. I think we're getting better now, so you can do more interesting things at the kernel level and in the hypervisor itself, which are much more lightweight. So it's not a new problem. I think container security and many of these models in terms of automating that are going to continue to be a major investment area. So we're never done, but it's certainly made a lot of progress in the last couple of years. Yep. Hi.
Okay. Machine-to-machine trust and the software layers on top of that is going to be a massive area of opportunity for software companies in the future. Obviously, we can't use Google IaaS. How or what is Google's plan to incorporate blockchain into its cloud strategy?
So we have not announced any products around blockchain. Blockchain's, still obviously a pretty early technology. But I think in terms of the first part of your question, things like machine-to-machine and code attestation, we're actually externalizing a lot of what we do internally, which is a very different model. It is a very distributed model. It's not the distributed ledger of blockchain per se, but I think as that evolves, we do have some of our customers doing blockchain on top of Google platform. So yeah, we see the excitement around that model.
Yes.
Hi, thank you for the presentation and loved it. So I had a question around the granular security that you're providing. You mentioned that you have a risk profile for the users who come in. So can you just highlight some methods that you use to determine that risk profile?
Yeah, there's a whole team at Google that is looking at defining both for the internal environment for incident response and threat detection within the Google environment, as well as for cloud. And that sort of proxy example that I used, the example there would be an attribute that it could be based on a number of things. And there is a lot of data that we also externalize independent of cloud. I'll give a couple of examples. We do a lot of investment in security research through something called Project Zero. We're essentially investing a dedicated team around finding zero-day vulnerabilities. So that kind of thing can essentially be blocked, even though nobody knew it even existed, right? We also have a program called Safe Browsing, which essentially keeps a real-time database of all of the known phishing and malware sites. So essentially, once again, any user within the cloud is getting that essentially for free, because essentially we have that data and we can essentially make sure that if we see a transaction that is coming from a known malware site, we can block it. So any user in the cloud gets the benefit of that. We've also opened up a submissions API on the cloud for that same data service, so that if, let's say, we're working with a large payment system or a financial who is aware of something and essentially wants to make sure that that's known to the rest of the industry, we can do that. So that model of sort of collaborative security research is also one of the reasons why you see the largest financial services organizations saying, I can't do this level of research in my own environment. If this is the platform that essentially folks are doing it, I need to get to be part of that. We have obviously, eyes and ears in ways that any one company would not. But I think the other thing is around behavioral, analytics as well as anomaly detection, right? So with, let's say, vast sets of data, an individual user may not think that a spike on a Tuesday is a bad thing, but with vast sets of data and the context around, and this is a real example from one of the large financials who had like 16 PhDs building machine learning models for their own environment based on the operational data, right? So that's where those models that get trained for their environment may be assessing risk based on context that they would have that we may not have, which is specific to their environment.
Curious about the first time Thank you. I was more curious about the first time a user approaches, how does Google treat that user? Because you may not have a risk profile for that user.
Well, so it's not just risk, right? I mean, the first problem has been we onboarded a very large financial services company, and getting them into, those users into the identity store initially is just based on, who they are and the device that they're on and checks like that. Over time, obviously, that risk score just becomes an attribute. Right, so you can check on many things. If I'm Jennifer and I'm allowed to access this data in the U.S., but I'm in Germany and I shouldn't be accessing that data from Germany, that's an example where you won't know that unless you've essentially established that that's a rule that should be enforced at that enforcement point. Hopefully that was clear.
Hi, Google is known for its culture or maybe skepticism over technologies not invented here. And you came in as external person. Did something strike you as, oh, Google have better adopted some technology than trying to invent it from scratch? Or maybe Google is just of such a big scale that it's really hard to find something that would suit its needs?
Yeah, I mean, I think that's been a lot of my role as well. With the focus on the enterprise, obviously, enterprises aren't starting from scratch. So Snapchat and Spotify and these folks are all greenfield, right? So they just want to move fast. They'll use whatever works, and they'll engage very directly from an engineering perspective. For an enterprise like Citibank or someone like that, they have obviously a lot of processes, and they can't train everybody up on something new. So yeah, we've built out as part of the cloud platform a partner ecosystem, put a new VP of business development, built that partner ecosystem. A lot of my role is essentially working with the partners to onboard their capabilities into the cloud platform as well. Whether it's, NGINX or Palo Alto Networks or F5 or, folks like that. I think the other thing is that it is a balance because, like for Cisco, the transition to IP, right? In the early days, decades ago, when you had, a number of proprietary systems, SNA and AppleTalk and Token Ring and DECnet, you didn't say, rewrite all of that for IP. What we said was, cap that and then grow with IP on top, and over time, all the applications will be IP enabled. So it's a similar thing. I mean, that lesson I think is very relevant for cloud. And in fact, Vint Cerf, who essentially is the father of the internet, is now an evangelist at Google and talks a lot about with the evolution of TCP/IP. What happened was essentially to create an abstraction layer that said, I don't care what the physical media is, and I don't care what the application is on top. We have a protocol that allows those things to talk. So it's not just about an API. If you look at gRPC, it supports APIs, but it is a protocol, right? And that's the way that essentially we can abstract across various languages or different bindings or client libraries and say this is the model that data should be exchanged no matter how it was implemented. So that I think that commitment to standards and I think the investment that we're making to essentially understand where the enterprises are and understand a phased migration path to where they want to go and where we think we can go together is definitely the investment that Diane Green has been very focused on. Diane was the founder of VMware, obviously has done a number of startups and was on the Google board. I think this transition was a lot about investing in the go-to-market. So essentially we could come to where the enterprises are, but not necessarily, but have them feel that we're accelerating them into a new, we're not going to reinvent what's been done in IT over the last 2 decades.
Jennifer.
Sure.
Hi, for the machine learning algorithms, can you talk about how the Google team takes ethics into consideration?
I love that topic. I mean, I'm very proud. I've only been there a year, but I'm if there's one thing about Google, it's the culture and the the non-technical aspects of the people in the culture. As an example, I just brought on to our team a new lead for privacy, and we think of privacy as actually quite different from security. although they're related, but building the user trust and being very transparent about what we're doing with user data, as well as giving the users the opportunity to understand and set their sort of privacy settings is something that we've been doing for a long time in Chrome and other. Now in cloud, obviously there's a big commitment to essentially your data is your data, and that's why things like the sensitive data classification, detection, and redaction is essentially something that users can take advantage of, but if they don't want to, then obviously that's their prerogative. So it's a critical part of delivering these technologies, which I think is something that Google makes a major investment in, not just because it's the right thing to do, but it is, in the end, the most efficient way to move these things forward. People are really focused on, managing risk, and obviously with the very public breaches that have happened recently, people 2 years ago, the sentiment was that cloud is not safe and secure. And now, if you look at the number of breaches that have happened on-prem for many of these enterprise customers, they just can't invest to get ahead of it. So they need to essentially get to a place where you have hundreds of engineers and the open source ecosystem dedicated to that. Another example, and this is, for machine learning, I think that's part of the reason why the community approach is also very important, because there's a governance model there that is not determined by just a corporate entity. If you look at the Cloud Native Compute Foundation and the governance model there, obviously Cisco is part of that as well. There's a governance model that essentially says these are, let's say, some of the lighthouse leaders in the industry, and we're going to come up with a model for how the industry moves forward together. And that's why a lot of these things get contributed in that environment, so that very early on, you're not setting a precedent that is just the opinion of one entity.
Hi, I have a question that kind of naturally follows from that question around security and trust, but more from a product management perspective. So in this business environment where we're moving towards cloud, data is essential to most services, and data protection is so fundamental both to the customer and the provider. And you could argue that security and the various aspects of security, it's not just a product on its own, but it's something that needs to be built in across the portfolio and kind of as a fundamental part of that portfolio. Can you tell us a bit about how you think about that from a product management perspective in terms of product management at Google as a data giant in the industry?
Yeah, I think that's one of the most interesting things, at least, an area of enrichment that I've found since being, at Google. It's a very developer, obviously friendly and driven environment, but I think that gives them the ability to upstream way in the life cycle of an application good practices around how things are developed. And when, let's say, code is checked into a repository, essentially not anyone can check it in, is checked, are you the person that should be checking this code in? And when the code is essentially, or when an API is called, it is essentially authenticated against a backend that knows that thing should be in the system. So that is a very different model, because I think before, if you look at sort of the enterprise security model, in the last decade, things grew up sort of siloed and in boxes, and each vendor kind of had their way of doing it. And a lot of the goal of the IT administrators and organizations was to integrate that. So, I'm a little biased because I was on the founding team of a software-defined networking company, but I think a lot of it is, everything should be loosely coupled and exposed through APIs, not locked into a specific model of a vendor implementation, and assuming that one implementation is the way that everybody will do it. The model of binary authorization and code attestation is something that is very much the way that it works within the Google environment. On the one hand, all the development teams can, have pretty transparent access to other code bases, like in the open source community, and yet, everything is logged, and essentially, access rights are watched, and essentially the authorization for any, code that's checked in is much more granular than a lot of the places that you might have seen. We also had, some of our customers talk about, as they move to more of a continuous integration, continuous deployment environment, it's not just the technology, but it is really a mindset and a sort of development philosophy change that I think kids out of school, it's easier for them, but it's very hard to take a developer who's been kind of working in the same environment for some time and move them to that type of environment.
So you'd say from a product management perspective, your goal is to really integrate security
Way upstream.
Okay.
Absolutely. I mean, security is cultural as well. It's a way of thinking. At Google, it's very much everybody owns security. It's not, just one team that owns it. And also, we talk a lot about a shared responsibility model. So there are certain things that we do in the platform that essentially we're responsible for, like hardening the kernel and essentially making sure that we're working on, trusted servers that essentially have the hardware root of trust at the base. But there are certain controls that we give to our users. And depending on whether it's a SaaS deployment, PaaS deployment, or a infrastructure as a service deployment, that line essentially is at a different point. We productize all of them.
Right.
You can consume raw compute resources, or you can consume Google App Engine or Red Hat OpenShift or Cloud Foundry. We just announced a major partnership with Cloud Foundry, who's now moving to Kubernetes and that model of managing containers. So whatever the PaaS layer is, that essentially implies a different level of shared responsibility. And then obviously, if it's something like Google Apps, G Suite, we're managing the entire app. So we're not expecting that folks are setting security policies for the specific components within the infrastructure.
Right. So security is really built in across the platform, across the
Absolutely.
entire service and offering.
And as a product manager, by the way, when you are doing a launch of a specific capability, it is checked at every gate.
Okay.
Right. So I approve a lot of the launches that happen within the team. For each gate within alpha, beta, or GA, we're doing essentially privacy reviews, et cetera.
Thank you. Very helpful.
Sure. So the sandwiches are hitting. Food coma. Just one.
I have a more generic question. Seeing all these shifts happening, what are some of your suggestions in terms of areas that we should be concentrating on as individuals, engineers, not just women, but men? Couple of future-looking advice.
I mean, I think, in a geeky way, I always want to surround myself with people that are smarter than me and be learning all the time, which I think is, Google has sort of a campus-like environment. It's almost like, being back in college. Constant talks and, book clubs. And is that a sign? Yeah.
That's what we do.
Yeah. And I look at, my 13-year-old son. He'll go away for, go into his room and come out being the master of the Rubik's Cube, right? Watch a couple of YouTube videos and suddenly he's the master of that. And I think that comes in very short bursts. I think that's very much the culture within Google and something that I really admire about the culture. And as a sort of personal attribute in a geeky way, I just, want to be surrounded by smart people doing cool things and learning constantly. Yes.
Oh, sorry.
So thank you for the second opportunity. This is more around partnerships. Some of the key alliances that have happened in the cloud space are AWS, VMware, and then Google entered into a partnership with Intel for making very customized chips. Can you talk a little bit about how you see partnerships expanding and influencing the public cloud market?
Yeah, I mean, I think we announced a partnership with Intel around things like IoT and the chip development. We also announced that we're the first to implement Skylake processors, in the cloud environment, and a lot of that just comes with building trust in the technical relationship with the partner community. So the engineers have been working very closely, and not hampered by. Obviously, you have to have some level of business governance, but I think sometimes the concerns around legal ramifications, et cetera, slow down the progress of the partner community. That's one area where, for instance, when we open sourced TensorFlow, we did it under the Apache license, which is the most permissive license that you could do. And a lot of that is essentially to accelerate the ability to actually get to the technical work and not have a lot of the overhead of legal agreements and the business development processes. So I hope that that's kind of a model for cloud that is a lasting model. Even when I was at Cisco, I think we had a 200-person mobility ecosystem partnership program that I was obviously very involved in, and I think a lot of the partner mentality continues to be partners who are motivated and invested in essentially a partnership will do the heavy lifting up front to make the partnership successful. So in the mobility ecosystem here, I think Cisco does a nice job of essentially getting to that sort of tiered model that essentially is very clear about what are the joint exit criteria and the success metrics for a successful partnership. And I think that's, nobody knows where we'll end up with this, but I think there is a level of, trust and transparency that has to happen. Even in Contrail, we had open sourced our code under the Apache license. Part of the reason for doing that was, number one, the engineers wanted to move fast. Number two, that's the way the ecosystem was going, and the things that were innovating the fastest were essentially already in that model.
In that case, I'd like to just
Oh,
thank Jennifer
boy.
for presenting today
Oh, thank you.
and coming back to Cisco as a presenter. Yeah. Thanks so much for coming, and if you can take a moment to fill out the survey, even if not everything, maybe parts of it, I'd really appreciate it. And I'll announce the next month's session on Monday. Thank you.